In this section, we'll be looking at ellipses. And I want to introduce ellipses by way of thinking of them as just a squished form of a circle. So we know that an equation of the form x squared plus y squared equals r squared is a circle of radius r centered at the origin. We went over that in our second pass through section 1.9. Now I'm just going to take this equation and write it in a slightly different way. If I divide both sides of this equation by r squared, then the equation looks like x squared over r squared plus y squared over r squared equals 1. And I want to look at it in this way on purpose because this is what most naturally leads to looking at ellipses. So in example 1, I ask us to graph x squared over 16 plus y squared over 16 equals 1. So the first thing I want to point out is that if I were to multiply both sides of this equation by 16, then you would see that this equation is the same as x squared plus y squared equals 16. And we know that that's a circle of radius 4 centered at the origin. Now, another way of thinking about what it means to have a circle with center of a circle with radius 4 is if you're at the center, then you can go out 4 units left and right, and you can go out 4 units up and down. And I want to think of that 4 as coming from these denominators. So think of the denominator under the x term as telling us how far to go left and right of the center. So 16 is 4 squared, and normally we think of 4 as the radius, but instead here I just want to think of it as instructions as telling us to go 4 units left and right of the center. And then underneath the y term, again we have a 16. 16 is 4 squared, and I want to think of this 4 as telling us to go 4 units up and down of the center. So to graph this, I can start at my center, and then 4 units left and right, and 4 units up and down, and graph. And notice that, of course, this is just a circle of radius 4. Again, one way of thinking of the radius tells us that we can go 4 units in any direction, but it's hard to count exactly what 4 units would be in any direction other than directly up, down, left, or right. So I can just think of the radius as telling us to go 4 units left and right and 4 units up and down. And those numbers occur under the x term and under the y term. So then the natural question is, what if we took this equation, but instead of these 16s being the same, what if we had different numbers under the denominator? So if I had x squared over 16 plus y squared over 9 equals 1. Well, then I claim it stands to reason that, again, we would get a circle-like figure centered at the origin, but we're not going the same number of units left and right as we are up and down. This 16, which is 4 squared, still, just like in this case, tells us to go 4 units left and right of the center. But then we have a different number under the y term. 9 is 3 squared, and so that tells us to go 3 units up and down from the center. So I start at my center, which is the origin, go 4 units left and right, and go 3 units up and down, and connect. So this looks like something like a squished circle. If we took the circle and we squished it some amount together. Well, that's what an ellipse is. An ellipse is like a circle, except you can think of it as having 2 different radii. We have a left-right radius and we have a vertical radius. It's not technically right to call that a radius if it's not the same in both directions, but that's the idea. There's technical names for this, like the major axis and the minor axis, but I don't care about that vocabulary for this course, so we'll just call it the left-right distance and the up-down distance from the center. So here's a summary of what we just said. The equation x squared over a squared plus y squared over b squared equals 1 represents the graph of an ellipse centered at the origin. And again, loosely speaking, you could just think of an ellipse as a squished circle. A tells us how far to go left and right from the center to get to the ellipse, and B tells us how far to go up or down from the center to get to the ellipse. So this equation is in this standard form. 9 is 3 squared, and so A is 3. And 4 is 2 squared, and so B is 2. So I just start at the center, and I go 3 units left and right, and 2 units up and down. And there's the graph of my ellipse. Simple as that. This equation is not in this form, but we can get it into that form just by dividing both sides by 144, since we want the right side to be 1. And then I want to reduce these fractions. You could do that with the help of your calculator if you like. Let me remind you a slick way of doing that. If I want to reduce 16 over 144, press enter. It gives it to me as a decimal, but I can get it to turn that into a fraction just by pressing this button. It's 1/9. So this becomes 1/9 x squared, or same thing is x squared over 9. And then similarly, you can reduce this fraction. You'll find out that it's 1/16, and so this is y squared over 16. And just like that, it's in the standard form of an ellipse. 9 is 3 squared, so A is 3, and 16 is 4 squared, so B is 4. So I start at the center, and I go 3 units left and right, 4 units up and down, and I've got my ellipse. In section 11.4, by the way, we'll look at ellipses that aren't centered at the origin. But for this section, we're just looking at ellipses that are centered at the origin. Now we have a couple of examples where we need to find the equation of the ellipse ourselves, either given the graph of the ellipse or given some information about the ellipse. So in example 4, we're asked to find the equation of an ellipse that is centered at the origin and whose x-intercepts and y-intercepts are given. So let's sketch a graph. X-intercepts are plus or minus 1, 0. So 1, 0 and negative 1, 0. And the y-intercepts are 0, 3 and 0, negative 3. Well, let me just start by reminding ourselves that the standard equation of an ellipse centered at the origin looks like this. And so our goal is just to figure out what A and B are. And of course, we can tell that immediately from the picture, right? A is the horizontal distance from the center to the ellipse. That's 1. And B is the vertical distance from the center to the ellipse. That's 3. So I just stick those into the equation. X squared over 1 squared plus y squared over 3 squared equals 1. And it probably wouldn't be the end of the world to leave it like that, but I'm going to clean this up. 1 squared is 1, and x squared divided by 1 is just x squared. And then 3 squared I'll write as 9. And there's the answer. All right, example 5. We're trying to find the equation of an ellipse. Again, it's centered at the origin. So we know that our equation is going to take this form. And again, our job is to find A and B. Well, A is given to us, right? A is the horizontal distance from the center to the ellipse, and we can see that that's 16. So I know that so far the equation looks like this. And I need to find B. I can't tell B just by looking. B is this vertical distance, and I don't know what that is. It doesn't tell me what that height is. It's not 6. 6 is after we've gone down a little bit. Well, what I'm going to do is I'm going to plug in the coordinates of this point. Here I've got an x value and a corresponding y value that satisfies the equation. So if I plug those in, then I can solve for B. So I get 8 squared over 16 squared plus 6 squared over b squared equals 1. So we just need to do the arithmetic there. You could do that with the help of your calculator. You square these and reduce the fraction, you'll find out that it reduces to 1/4. That's 36 over b squared. Subtract the 1/4 to the other side. 1 minus 1/4 is 3/4. Then I want to clear fractions from this equation. I can do that by multiplying both sides by the LCD 4b squared, or you can use the technique of cross-multiplying if you know that. If you have an equation that's of the form fraction equals fraction, then the product down one diagonal equals the product across the other diagonal. So in this case, it's 3b squared equals 4 times 36, which is 144. Now to solve this equation, I divide away the 3. 144 over 3 is 48. So b squared equals 148. So b itself equals the square root of 48, but I don't even need to know that or write that down, because remember, our goal is to just fill in this equation, and this denominator just requires having what b squared is. And I already have that b squared is 48. So let's just leave it like that and substitute this in directly to this equation right here. So my answer then is that the equation of this ellipse is x squared over 16 squared, which is 256, plus y squared over b squared, which we just found is 48, and that equals 1.